Well, hey there, kiddos. We are going to start talking about something called factoring today, which up until now, the test that you took today in class was all about multiplying polynomials together. Factoring is the opposite of that. It's how we divide a polynomial. We don't call it division because that's not what you're doing. You're factoring, but it's the opposite of multiplying. So in essence, it's like a multiplication problem. What we're going to do today is factor using something called the GCF, which is something you should know, something that you learned before. And so you've seen this before. If you need a refresher on how to find greatest common factor, there is a very short video that my daughter made on my YouTube channel called Mackenzie Finds the GCF, and you can go watch that video for a refresher on how to find GCF, or you could probably go to Khan Academy and look it up. But if you need a refresher, there are plenty of them out there. We are going to talk about a new part to GCF because what you've done before was only GCF for numbers. Now we're going to have GCF that's also going to include variables. Excuse me. So this very first problem, we have 8ax minus 56a, and they want us to factor it. And the only way to factor it is the first thing I have to do is name the GCF. I've got to talk about what the greatest common factor is between those. So the greatest common factor for this, 8ax and 56a. I have to talk about what they have in common. So let's do the coefficients first. 8 and 56. I need the greatest common factor of 8 and 56. And you can draw your little factor tree or do whatever you need to do, but the largest number that goes into both of those is going to be 8. So my GCF for this is going to be an 8. Now I have to talk about what else they have in common because this has an AX and this has an A. Well, if you will notice, they both have an A as part of their term, so they also have an A in common. So the greatest common factor for both of those numbers is 8A because they have an 8 in common for the coefficients and then they both share an A. So when I factor this using the greatest common factor, what I'm going to do is I'm going to take out that 8A. And then in parentheses, I'm going to write what is left, what I still have remaining after I pull that 8A out. Okay, what should happen at the end is that this 8a times what I'm going to put in parentheses should equal what I started with. This is what I mean by it's sort of like dividing. I have the 8 that I already need, and I already have the a. In order for 8a times something to make 8ax, I have to have my x still. So that goes in the parentheses. So now if you do your distributive property, 8a times x makes 8ax. So you see what I did? My minus sign is going to stay. Now, 8 times something has to give me 56. I need the something to go here. Well, 8 times 7 is 56. So when I multiply those check. And here is the A I have out here already. And I don't need to put it again because I only needed one A to begin with. So my A is already here. So those are my two factors. And if I do the double distributive property and multiply this out, it should equal this when I'm done. So we can double check it. That becomes 8ax. And then when I do 8a times negative 7, it becomes negative 56a. So this is the same thing as this. So my two factors is this part right here. This is your answer. You do not have to multiply them together every time and check. I just wanted you to see that it worked. So now let's talk about number 3. We're going to do the GCF for number 3 up here again, just like we did for the one a minute ago. So I have 35a squared b cubed c, and I have 40a cubed b squared c squared. And I need to find the GCF for those two terms. I'm not going to worry about this plus sign right now. I'll deal with that when I factor, but first I got to have the GCF. Well, the greatest common factor for 35 and 40, the largest number that will go into both of them is a 5. Now when I'm doing my variables, here is how you want to look at it. So I have a squared and a to the third. So what that means is up here I have a times a, and over here I have a times a times a. And hopefully you notice that they have two a's in common. This one has an extra a hanging out, which is not a big deal. We'll take care of that when we factor. But as far as greatest common factor, the largest number of a's they have in common is 2 of them. And so when I'm doing this, I don't write it out like this every time because it gets to be a pain in the butt to list them all in expanded form. But if you'll just look at their exponents, I've got a squared and a to the third. Well, a squared has a smaller exponent, so that becomes my GCF. Whatever your smallest exponent is with the variables, that becomes your greatest common factor, because that's the largest number of those variables they have in common. So now let's look at the b's. I've got b to the third and b squared. Well, the one with the smallest exponent is the b squared, so that's my GCF. And then for the c's, I have c, which is c to the first, because there's that imaginary one, and then c squared. Well, c to the first is the smallest, so that's part of my GCF. My entire greatest common factor for these two terms is 5a squared b squared c. So when I factor, the first thing I'm going to do is write down what my greatest common factor was. I'm going to pull that out. Then I have to multiply that greatest common factor times something to give me back my final answer. So now it's just working backwards. 5 times some number in here has to equal 35 when I'm done. Well, 5 times 7 makes 35. Then I just go to looking at my variables and what do I have that I've pulled out and what do I need in my final answer? Well, I have an a squared. I need an a squared when I'm done, so I'm finished with my a squareds for this term. I have a b squared, but I need a b to the third when I'm done. So that means I need one more b, so I have to include it here. I have a c, I need a c, which means I'm done with my c. So if I multiply this great GCF times this, I should get that first term. Now put your plus sign. Now 5 times something has to give me 40. Well, that something is 8. Then I check again. I have a squared that I've taken out. I need a to the third, which means I need another a in here. I have b squared. I need b squared, so I don't need any more b's. I have one c because I have a c to the first. I need a c squared, which means I need one more c in here. Those are my two factors for that polynomial. So if I multiply those two things together, double distributive property, I'm going to end up with that original problem that I got. And you can go back and check it if you want. So let's do number 4. So let's talk about the greatest common factor. Let's look at coefficients first. I have a 3, a 9, and a 36. Well, the biggest number that goes into all three of those is a 3. Now let's talk variables. I have x to the third, x to the first, and x to the first. The one with the smallest exponent we get to take out. So that's an x. Then I have a y to the first, a y squared, and a y to the first. Again, y to the first is the smallest, so I take that out. In parentheses, let's talk about what's left. I have my 3, so we're good there. I have an x, but I need x cubed. So I have one of them. That means I need 2 more in here, so I have x squared. I have my y here already. I need a y, so we're done. Minus sign, because that's what's here next. 3 times something is going to make 9. Well, that's a 3. I pulled out the x already, so I'm good with my x's. I pulled out one y, but I need y squared, so I need another y. Put your plus sign. Now 3 times something makes 36. That something is a 12. I pulled out an x, and I'm good because that's all I need. I pulled out a y, and I'm good there because that's all I need. So there is my other factor. And if I multiply those two things together again, like I said, distributive property, it's going to give me that first term. So that's your goal for factoring. What are the two things that multiply together to make the original thing? That's what we're trying to do. And with polynomials, it just takes a little extra work. But this thing with GCF is going to have to be something you get really good at because it doesn't go away, as you will see in the next two problems. They ask us to express those polynomials in factored form. What that means is factor. Tell me the two things that multiply together to give me that problem. So we're working backwards. There are two ways to do this. I'm going to do number 5 one way, and I'm going to do number 6 the other way, and then you pick the one you like the best. The first way is what I like, is what we call the grouping method. And so I take the first two and I group them together. And so then I take the second set and I'm going to group them in parentheses. So now I have created two groups, hence the grouping form, or the grouping method. So now I'm going to take these two terms that are in a group and I'm going to pull out their GCF. So I have Rx and 2Ry. The only thing these two terms have in common is an R, so I'm going to pull it out. Just like I did up here with one, it should say 1, 2, and 3. Then in parentheses, we're going to put what's left. Well, I've taken out the R from the Rx, which just leaves the X. And I've taken out the R from this 2Ry, so I have a 2Y left. Now there was a plus sign here, so I'm going to bring it down. Now these two terms, the only thing they have in common is a K, so I'm going to pull that out. So I've taken out the K, so that leaves me with an X. and a 2y. Now you should notice that these two little bits that are in parentheses look exactly the same. If they do not, when you do the grouping method, you have screwed up somewhere. So they have to look the same. So that tells me that one of my factors is x plus 2y because those matchy-matchy. My other factor is the stuff that's not in parentheses, this r plus k. So these are the two factors. Now you do not have to do grouping method. If you just decide you hate the grouping method, that's cool. Remember the box from when we multiplied? You can use the box to factor. So we draw our box. It's a box with a 2 by 2 box because I have 4 little terms, and I'm just going to fill this in. 6n cubed goes here, 8n squared goes here, 3n here, and 4 here. Then I'm just going to go row by row and column by column and pull out the GCF. So this top row right here, the greatest common factor between 6 and 8 is going to be a 2. And then the greatest common factor between n to the third and n squared is that n squared because it has the smallest exponent. Then down here on the bottom, the greatest common factor between 3n and 4, the only thing those numbers have in common is a 1. So I'm going to factor that out. Then this row, the greatest common factor between 6 and 3 is going to be a 3. And then they both have an n in common. And then for 8n squared and 4, the greatest common factor there is a 4. So this gives me my two factors. One of them is 2n squared plus 1, and the other one is 3n plus 4. Now the next question wants us to write an expression in factored form for the area of the shaded region. Well, before we can do anything, we got to find the area of the shaded region. So that's where we're going to start. This great big rectangle is the little rectangle with 6 added on each side. And here's how I got 6. I added 3 to the left and 3 to the right, which means I added 6 total all the way across. So my length here is y plus 6 because I added 6 to this y. And my width here is x plus 6 because I added 3 on the bottom and 3 on the top. So when I find the big area or the whole thing, I have to multiply these together. So I have to do x plus 6 times y plus 6. And so we do what we learned in the last unit. We do our double distributive property. X times y is xy. X times 6 is 6x. 6 times y is 6y. And 6 times 6 makes 36. There are no like terms. We can't combine anything together. That's all there is. Now for the small area, I just multiply these two things together. Well, x times y is just xy, so I have to subtract that from what I had. They made this real easy. xy minus xy, they cancel each other out. So what you have left is 6x plus 6y plus 36, and they want the answer in factored form. So now I have to factor this. Well, the greatest common factor between those three things is going to be a 6, and that's all they have in common. So I factor out the 6. That leaves me with an x here and a y here, and 6 times 6 is going to make 36. This is your answer in factored form. So pause real quick, use what we've learned, see if you can do that last one, find me, go ahead and factor that 4-term polynomial, and then come back and see if you've got the right dimensions. Okay, so what I've done is I have grouped these. Here is how this one is different, is that it's got this minus sign before the 10x, and that's going to affect your factoring. So I've grouped them together, and for this first one, the only thing they have in common is an x. So I factored it out, and when I did, it left me with a 5x and a plus 4. This one right here, the greatest common factor for 10x and 8 is going to be a 2x. My bad, it's just a 2. There's no x there. Okay, so it's just a 2, but I'm going to pull out a minus 2 because of this minus sign right here. I have to take care of that. And so that's going to affect when I factor, because if I do negative 2 times 5x, that makes the negative 10x. But when I do negative 2 times positive 4, that's how I get my minus 8. So you have to make sure that this number multiplies times this to make what you originally had. Some of you probably went ahead and put a minus sign here because that's what you had to begin with. But if you leave that minus sign, this minus sign and that minus sign are going to make a plus, and it's not what you started with. So you have to double check. So my two final factors, or a plus, then your two parentheses sets don't matchy-matchy and you have a problem. So that's usually what's going to happen. Why your parentheses don't match is because you've messed up with a sign somewhere. You should always go back and double check it. And by double check, I mean actually look at your work. Don't just all of a sudden make something match just because you know they're supposed to. Go make sure the math works. So now you have 5x plus 4 is one dimension, and x minus 2 is the other. And so if I were to draw my rectangle for the foundation of the new high school, this would be 5x plus 4, and this would be x minus 2. So that is factoring with the greatest common factor in grouping. We will practice when you come to school tomorrow, and I will see you then.